Howdy, HL. We just got off our Zoom call, and I couldn't help you with this particular problem, but after checking the back of the book, I have a little better sense of things. And so what I did here is we're looking at number 2 from the book. It says, attempt to prove that root 4 is irrational using the method in example 10 and explain why the argument fails. So what happens is in example 2, they're proving that the square root of 2 is irrational by saying we're going to assume that it's rational, and therefore it has to be, it can be written as p over q, where q is not 0, and that's a reduced fraction. So then you square both sides, and you come up with that p squared is equal to 2q squared, which implies that p is even, or p squared is even, so therefore p must be even. Now this was something we proved in the chapter on proof by exhaustion, and this is actually a video I made yesterday. So, so go look at that one right here. So therefore p has to be equal to 4k, so then we can substitute that back in right here. Oh, that's a funny color. Okay, sorry, I'm getting a little excessive. And then it gives us this 4k squared, and therefore then we cancel giving, we end up saying that q squared is equal to 2k squared, which means that q squared is also even, so q must be even. But we just said that they had, they're both even, both p and q are even. But we said that they are in lowest terms, so they can't both be even, because then they both could have a 2 factored out. So that's what happened with that one. So when we try for the other, well, and then I noticed, I went to the back of the book, and I saw that the hint for this one is if p squared is a multiple of 4, then p is not necessarily a multiple of 4. So we said, okay, so we tried, I followed this example, like I followed word for word. Suppose the square root of 4 is rational. So root 4 is equal to p over q for some positive integers, p and q not equal to 0. P and q have no common factors. Okay, so then we started here, we squared both sides. Then this got us to where we're saying that p squared is a multiple of 4. Okay, so in the previous example, once we had p squared, we didn't say p squared was a multiple of 4. In the other one, we said p squared was a multiple of 2. And if p squared is a multiple of 2, p has to be a multiple of 2. If p squared is even, p is even. But in this one, it does not follow that just because p squared is a multiple of 4, that doesn't necessarily mean that p itself has to be a multiple of 4. You can take, for example, if p equals 2, then p squared would equal 4. If p equals 6, then p squared would equal 36. Both of those are multiples of 4, but their original p that they came from is not a multiple of 4. Okay, so that's kind of where this reasoning falls apart. We can't make the same assumptions about them both being multiples of 4, and therefore it isn't reduced. And so, yeah, that's kind of how I think we want to address that problem. I don't expect IB to ask a question like this, but we, once again, don't know at this point. So I hope that helps a little bit. I'm sorry I couldn't give you better advice when we were on the Zoom, but here we go. So, all right, good luck. Go practice.